On to stage 4 now, and we're going to look at handling concurrent connections to our server. Up until now, when we receive a connection, we run a loop which will block the main thread while it reads and writes to that single connection. And while that connection is active, our code won't ever check whether there's another connection coming in. So in order to solve that, we either need threads, or if we're feeling adventurous, we can go and use an event loop. So for Rust, the event loop of choice would be to go to Tokyo or async standard. So I'm going to use Tokyo, and that gives us access to the async await syntax and has libraries for doing concurrent network programming. So let's start with the Tokyo documentation. This piece of code we've got here is like a skeleton for doing a TCP listener and accepting connections concurrently on Tokyo. So you can see we're getting TCP listener, which is a type we're already using from standard net. We're getting it from Tokyo net instead. And that means we get access to this wait syntax, so we can wait for the port to be bound, we can wait for the next connection to arrive, and then when we do get a new connection, so a new client connecting to our server, we can use this Tokyo spawn to launch a new task on Tokyo, which Tokyo will run asynchronously. So whenever we're waiting for a client to send us data or waiting for data to be sent out over the network, our task can get suspended while other tasks run. So the details of this are not too important, but it's similar to threading, except that we don't have to worry about the details of the threading ourselves. We can just worry about writing code, and we can tell Tokyo when we're going to pause while we're doing network operations. So let's try and move the stage 3 forwards to use Tokyo and see how we can set up concurrent connections. Converting this over to work with Tokyo is going to take a few steps. So the first step is to add Tokyo as a dependency, which we don't have to do because it's been provided for us as part of the template. So we're running a new enough version, and we've got all the features of Tokyo turned on, so we'll have everything we need. So then in the code, there's a few things to change. The first thing is going to make main an async function. That's not supported in Rust, so to make that work, we need to add Tokyo main to that, so that this main function gets kicked off with the Tokyo runtime. We don't want to use any type from standard net, so let's replace these imports with an import from Tokyo. So use Tokyo net TCP listener. There we go. So that will now be the Tokyo listener. We bind to the same port, so the interface is very similar, but that is now something we do asynchronously. So we await that, which will give us our listener. The listener doesn't have an incoming, it has an accept, and that again is asynchronous. And then it makes less sense to set this up like this. So because we're awaiting and that's already an event loop, it doesn't really make sense to be trying to do a for loop over it. So we'll just keep trying to accept connections. Call that our stream. So accept connections, await, and then we'll match on that if it's okay. Now there's a difference here in the API. When you do incoming on a standard net TCP listener, it just gives you back the stream, the connection that you've been given. Tokyo gives you back a bit more. It gives you back both the stream and the remote that's connected to you. So information about like their IP and the port they were connecting off. And we don't need that. So this is just a tuple. So we'll say, give me the stream, which is the first thing that comes back. Don't give me the remote connection information because we don't need it. Okay. So we can now launch this code in a task. Spawn, async move, and then we'll move all of that code inside there. So the async makes this be an async block of code, so it treats it like a future, similar to a promise if you're coming from JavaScript or anything like that. And the move is a Rust bit of syntax that says when you capture state into this block, move it to this block so this block owns it. So the thing we're capturing here is the stream. So we're saying this stream that we've just accepted, move it and make it part of the state of this task. So when this task ends, that stream closes. It's not owned by the loop. Nothing has to keep it alive. It's ours to look after. So we can create a buffer just the same. We can read from the connection just the same, but that's now asynchronous. So we need to remember to await the result of that read. And the same with the write. Now I was hoping my IDE was going to give me a hint here for what to import for read and write, because we had to have trait imports for those for the standard net version of this. So I'm going to let the compiler tell me instead. So if we try and build this code. Okay, got some syntax errors, so let's fix these. So starting from the top, it doesn't like the read, and it's telling us to import Tokio.io async read extension. And I'm pretty sure there'll be a paired write extension, so let's just try and import that. Yep, write extension. And then we've got logic error here somewhere, so where have we gone wrong? That should have a semicolon on it. That might be enough. Okay, yeah. So just anything that's the last value in a block in Rust will try and return. So we're trying to return the value of Tokyo spawn here. So putting a semicolon on suppresses that because we're not expecting it to return a value from this match block. Okay, so that should be the code. Let's see if it works. So if we try and start this up with spawn, cool. And then I'll switch to a new terminal and split that terminal if VS Code will let me. Not sure how to do that. Right, we'll just do 2 then. So if we connect with netcat to localhost 6379, cool. And send a ping, we get a pong back. If I connect over here at the same time with a second netcat, 6379, we can send messages, and that first one should still be working. Cool, so that looks good. So we're able to connect with 2 clients at the same time and send pings to our server. We don't have to connect, use the server, disconnect before someone else can use it. So let's see if that passes the tests. Excellent, that passes the tests. So we're done with stage 4.